It was the early 1950s. The United States had won World War II, but a new battle was about to begin, that of infrastructure. The country was growing rapidly, and automobiles were multiplying in American garages. But the roads were not keeping up. They were uneven, fragmented, and often impassable for long distances. Driving across the country from coast to coast was a risky and exhausting adventure. It was in this scenario that the figure of Dwight D. Eisenhower, then President of the United States, emerged. Inspired by a remarkable experience during his youth when he participated in a military convoy that took 2 months to cross the United States on poor roads, and even more impressed by the efficiency of the German Autobahn, Eisenhower made a decision that would change the course of the country forever. In 1956, he signed the Federal Aid Highway Act, an audacious bill that called for the construction of more than 41,000 miles of interstate highways. It wasn't just a transportation plan, it was a national security strategy. In the event of war, troops and supplies would need to move quickly across the country. It was also an economic move to connect cities, open access to rural areas, and encourage commerce across the country. The plan involved 90% federal funding and only 10% state funding, which made it easier for states to join. Projects would be standardized, monitored, and tested with extreme rigor. This was the beginning of the construction of what would become the largest and most durable highway system on the planet. But it wasn't just strategic vision that made these roads legendary. What many don't know is that the secret behind the longevity of American highways is literally hidden beneath the asphalt. And that's exactly what we'll explore in the next chapter. While the eyes of the world saw only the brightly painted lanes and black asphalt gliding between deserts, forests, and mountains, the true strength of America's highways lay hidden beneath their surface. The secret to their durability wasn't magic, it was science, precision, and an almost obsessive investment in engineering. Unlike many highways around the world, U.S. interstates were designed with multiple foundation layers, each with a specific function. From the subbase, composed of compacted gravel and drainage calculated to the millimeter, to the top layers of concrete or asphalt with special additives, everything was carefully tested in the laboratory before taking shape in the ground. This solid base not only distributed the weight of the vehicles, but also prevented the ground below from freezing in winter or swelling during heavy rains. In regions such as Alaska and Minnesota, for example, engineers used mixes with greater thermal flexibility, while in Texas and Arizona, the challenge was to withstand asphalt temperatures of more than 50-degree icing. In addition to the foundation, surface materials also underwent a real evolutionary leap. The concrete used in many highways was reinforced with metal mesh or polymer fibers, preventing cracks. Asphalt, in turn, gained compounds that increased adhesion and resistance to wear, in some cases with the reuse of recycled tires, which helped the sustainability of the system. Another difference was the testing standard applied in the field. Before opening a road, highway authorities applied load tests that simulated the impact of thousands of trucks per day. In addition, underground sensors and drones were used to monitor temperature variations, ground displacements, and even vibration caused by heavy traffic. This investment in quality was no accident. The U.S. knew that building cheaply could mean rebuilding early, so they chose to pay more up front to ensure highways that would last for decades with minimal maintenance, and it worked. An emblematic example is the stretch of Interstate I-80 in the state of Nebraska, built in the 1960s, and which remains in operation to this day with only occasional maintenance interventions, without the need for complete reconstruction in more than half a century. With these precautions, the highways became veritable corridors of steel and concrete. But the Great Revolution was not only technical, it completely changed the way people live, work, and travel in the United States. In the next chapter, we will see how this network of roads shaped the country itself and transformed what was once isolated into a connected country. When the first miles of interstate highways began to stretch across America's fields and deserts, few could have foreseen the magnitude of the transformation they would bring. The promise of mobility, integration, and progress seemed grand, but in practice, the impact was even more profound, culturally, socially, and economically. Until the 1950s, life in many parts of the United States was marked by isolation. Small towns in states like Kansas, Wyoming, or South Dakota were largely self-sufficient, but they were disconnected from the rest of the country. Travel between states took days, if not weeks, and goods took a long time to arrive, if at all. With the advent of highways, this scenario changed radically. Suddenly, a town of a few hundred people could be just a few hours away from a major urban center. Distribution logistics flourished. Supermarkets began receiving fresh produce more frequently. Trucking companies expanded their routes. Farmers began selling their crops across state lines. A new era of interstate commerce was dawning, driven by the steady roar of trucks crisscrossing the country day and night. But perhaps no industry was as impacted as tourism. The road became the stage for a cultural revolution on wheels. The 1960s and 1970s were marked by the iconic road trip. Families hopping into RVs or vans with folded maps in the glove compartment and Elvis Presley tapes in the player. Roadside motels flourished. Restaurants like McDonald's and Denny's grew up at these crossroads of the new American life. A way of life emerged, the road trip. And of course, there's one name that's become legend in this story. Route 66, known as the Mother Road. It wasn't part of the modern interstate system, but it represented the spirit of that change. Connecting Chicago to Los Angeles, crossing 8 states and 3 time zones, Route 66 became a symbol of freedom and adventure. Bands sang about it, writers immortalized it, and millions of people traveled it in search of new beginnings, business deals, or just good stories. But it wasn't all sunshine and rainbows. The creation of new highways also had its dark side. In the name of progress, entire neighborhoods were demolished, especially in poorer urban areas. In cities like Detroit, New Orleans, and Miami, Black communities were divided or removed to make way for concrete. The highway system connected the country, but it also tore many communities apart. Furthermore, the rise of the car as the primary mode of transportation reduced investment in rail and public transportation. Cities were designed for cars, not people. The suburban lifestyle took hold, living far away, working far away, all accessible by highway. It was practical, but it also ushered in a culture of heavy traffic, oil dependence, and mass pollution. Still, the overall result was growth. The interstate system doubled the US GDP in less than 30 years by facilitating the movement of goods and services. Universities became accessible to students from outside their states. Hospitals received supplies more quickly. And in critical moments, such as natural disasters or medical emergencies, highways were vital in saving lives. Interestingly, there are even roads built for secret military purposes. Sections that allow planes to land, armored tunnels that protect underground communication systems, and camouflaged evacuation points. All of this was planned, quietly, as part of the national security package. In the end, these roads were not just concrete paths. They were invisible bridges between worlds, between rural and urban, between past and future. They connected more than cities. They connected lives, dreams, stories. And for all of this to remain standing over the decades, it would take something beyond construction. Excellent maintenance. In the next chapter, we'll reveal how the US keeps this highway giant running with minimal deterioration, and what it does differently than the rest of the world. Building something great is an achievement. Keeping it running for decades is an art. And in the case of America's highways, that art involves a precise combination of technology, strategic planning, and a culture of conservation that has become a model for the world. The durability of America's roads depends not just on how robustly built they are, but on how well the country takes care of them. One of the biggest innovations was the creation of the concept of scheduled preventive maintenance. While in many countries roads are only repaired when they are already damaged, in the US there is a detailed map of each road section, with inspection schedules based on historical data, average daily traffic and weather conditions. This allows interventions to be made before the problem appears. Sensors installed in the ground throughout the territory measure temperature, pressure, vibrations, and even signs of millimeter-sized cracks that the human eye cannot yet detect. Cameras and drones carry out constant aerial surveys. And, in more critical areas, such as mountainous regions subject to landslides, Seismic and geological alert systems monitor any ground movement in real time. A striking example is California. The state, known for its seismic activity, has highways equipped with seismic shock absorbers, which reduce structural damage in the event of earthquakes. In addition, after extreme weather events such as hurricanes or snowstorms, emergency teams are activated with military readiness to restore damaged sections. Another difference is the use of smart materials. Some types of concrete used on interstate highways contain crystals that expand when they come into contact with water, sealing microcracks and preventing infiltration. Polymeric asphalt, used in areas with extreme temperature variations, has flexibility that reduces the appearance of potholes even after years of intense use. All of this is coordinated by federal and state agencies, such as the Federal Highway Administration, FHWA, which monitors quality standards and distributes funds based on strict technical criteria. States that maintain good conservation rates receive more funding. This creates a culture of accountability and excellence among local governments. Still, repairs and renovations remain commonplace, and the reason is not failure, but upgrades. As the vehicle fleet evolves, the U.S. adapts its roads to new requirements for weight, emissions, safety, and mobility. In some cases, entire stretches are rebuilt, not because they are damaged, but because they no longer meet modern standards. In the end, the secret is not in building something that will last forever, but in keeping alive the intelligence that allows that something to renew itself. And it is precisely this mindset that is shaping the next step for American roads. The future. America's highways aren't just symbols of engineering's glorious past. They're also becoming living laboratories for the future of mobility. As the world moves toward more sustainable, smart, and integrated solutions, the United States is moving to transform its already durable roads into even more innovative and perhaps self-sufficient structures. It all starts with the rise of electric vehicles. With the increasing electrification of the American fleet, the need arose to adapt highways to accommodate cars, trucks, and buses that need frequent recharging. The answer? Magnetic induction charging lanes. Pilot projects in states like Michigan and Indiana are installing experimental lanes capable of recharging vehicle batteries while they're moving, using coils embedded in the asphalt and smart sensors that detect the type of vehicle. And that's just the beginning. Another bold project involves the use of solar panels on the road surface itself. The idea is that highways will generate energy for streetlights, sensors, and even to supply small nearby towns. Although still in the early stages and with technical challenges, such as resistance to weight and cost, tests have already shown feasibility in places with high levels of solar radiation. In addition to electricity, the highways of the future are being thought of as data hubs. With the advancement of self-driving cars and the Internet of Things, IoT, every inch of the road will be able to send and receive information in real time. Imagine a stretch of road that warns your car of an accident 2 kilometers ahead, automatically reroutes your route or adjusts the speed limit based on the weather. This is already being tested on smart highways in the states of Nevada, Arizona, and California, where sensors and artificial intelligence communicate with vehicles and control centers. Smart roads also promise to put an end to chronic traffic congestion. Adaptive lane systems, in which the number of lanes automatically varies according to traffic flow, are being installed in dense urban areas. LED screens on the asphalt indicate the direction of each lane and adapt to the volume of traffic, all in real time. Another pillar of modernization is environmental sustainability. New materials are being developed to make roads more environmentally friendly. Among them, photocatalytic asphalt stands out, which has properties capable of cleaning the air by absorbing pollutant particles and breaking them down with sunlight. Porous concrete helps absorb rainwater, reducing the risk of urban flooding. Behind the scenes, highway management is also undergoing a revolution. Data analysis platforms make it possible to predict structural failures weeks in advance, calculate the impact of climate change in real time, and simulate traffic behavior during holidays or emergencies. This makes expansion, maintenance, and modernization plans much more efficient and cost-effective. Despite all this progress, challenges have not disappeared. Infrastructure expansion depends on continued investment, and debates about public funding, smart tolls, and partnerships with private companies remain on the agenda. In addition, there is the ethical challenge of collecting and using driver data on connected highways. The future requires solutions, but also caution. But one thing is certain: America isn't just maintaining its roads, it's reinventing them for the 21st century. What began as Eisenhower's strategic vision has become a living, breathing network that pulses with the rhythm of innovation. And what's most impressive is that even with the latest technology, the principle remains the same: connecting people, places, and possibilities. America's highways remain vital arteries of the country, but now they not only carry cargo and people, they also transport data, energy, and ideas. They are the link between the concrete and the digital, between the present and what is yet to come. At the end of this journey, it becomes clear that the secret to the world's most durable roads lies not just in the materials or the engineering, but in the forward-looking vision that has never stopped paving the way. If you enjoyed this journey through the world's most durable and intelligent roads, leave a like. This helps us continue to bring you quality content and stories that show how engineering transforms our daily lives. And of course, subscribe to the channel so you don't miss the next episodes about innovation, curiosities, and the behind the scenes of human progress. There is a long road ahead. Let's go on this journey together.